Dalton's law of partial pressure states that the total pressure of a mixture of gases is simply the sum of the individual pressures of each of the gases. These are known as partial pressures. Like in this container, we have two gases. I have 1, 2, 3, 4, 5 of whatever the pink one is representing, and 1, 2, 3, 4, 5, 6, 7 of the blue one. So the blue one is going to exert a greater pressure than the pink one would. We have two equations that we're going to be using. Our total pressure is equal to the sum of my first gas, my second gas, plus my third gas, plus my fourth gas, and so on. So you're just going to keep adding your gases up until you've run out of all the gases. Maybe you only have 2 gases, maybe you have 5 gases. And then their second equation is the partial pressure of whatever gas you're talking about is equal to the fraction of that gas times total pressure. So PT is equal to my pressure of my first gas, my second gas, my third gas, and my fourth gas. Looking at the problem, all of my gases are in ATM and I want my answer in atmospheres. So I don't have to do any pressure conversions. They said my first pressure, or the total pressure, is 4.8 ATM. My first pressure is 1.2 ATM. And notice I'm adding them up. My total is on the left, and then everything else is going to be on the right. My second gas, my third gas, and I'm looking for P4. So to solve this, I have addition going on, so I need to subtract. So 4.8 minus 1.2 minus 0.49 minus 0.78 is going to equal my P4. So subtracting those out, I get 2.33, and that's ATM since everything was in ATM. This problem is going to be just like the last one, except all of my units aren't exactly the same. But I do want my answer in torr. Since I'm going to have to convert lots of things, I might as well convert this one to torr and this one to torr and then plug it in. Also, because they told me the specific gases, instead of just saying P1, P2, I'm going to say P oxygen plus P xenon plus P helium. So when I plug them in, I know where each one goes. So step 1, go ahead and convert your pressure of helium to torr, and then convert your pressure of oxygen to torr. Then plug in and then solve for your pressure of xenon. So converting my 0.458 ATM, remember that there's 1 ATM for every 760 torr. So we get 348 torr. So 1 ATM is equal to 760 torr, which is equal to 760 mmHg, which is equal to 101.3 kPa. If you do not have that in your previous notes, you need to make sure that you write that down on this page so that way you have those conversion factors. So this one was my pressure of helium. And then you should have did the same thing with your pressure of oxygen. You had 74.1 kPa. And there's 101.3 kPa for every 760 torr. Multiplying and dividing, we get 555.9, which we can say is 556 torr. We know our total pressure was 972 torr. Our oxygen was 556 torr. We don't know the pressure of xenon, and helium you should have had was 348 torr. So just like we did before, we're going to subtract 556 and 348 over. So the pressure of xenon is simply 68 torr. Go ahead and pause the video and see if you can figure this one out on your own. Restart once you have the answer or if you are lost. So just like our first problem, they don't tell us what the gases are, but we do know that we have 3 of those gases. Remember that you don't always have 3. The first time we had it was 4. We could easily also just have 2 gases. They said that your total pressure was 1.27 atm. This one was in torr, and we want our answer in torr. So step 1 is you should have converted 1.27 atm to torr. If you haven't already converted this atm to torr, go ahead and pause the video and do that. So PT, converting that, you had your 1 atm is equal to 760 torr. That gives you 965.2, or just 965 torr. So that was your total pressure. Reading it along, it says 2 of the gases have the same partial pressure, but we don't know what those partial pressures are. So if you think back to math class, we usually represent an unknown with x. They're the exact same value because they have the same partial pressure, so I have x plus whatever this third gas is, which is 650 torr. So now, when solving that, I can subtract out my 650 and then combine those two x's to just give me 2x. So then I divide by 2. So x is equal to 157.5 or 158 torr. Besides word problems, you can also see problems where you're given a picture, like on the first page that we saw. In this problem, we have a container. We have 3 gases, argon, neon, and xenon. And it says, what's the partial pressure of argon in millimeters of mercury if the total pressure is 1140? So now we're going to be using that equation that we had on the right side, which was P1 is equal to the fraction of 1 times P total. But instead of putting a 1, I'm looking for the pressure of argon. So the pressure of argon is equal to the fraction of argon times total pressure. So to get that fraction of argon, I'm going to say argon is the open circle. I have 2 argon. I have 1, 2, 3, 4, 5 neon. And then I've got 3 xenon, which gives me a total of 10. So 2 out of every 10 are argon. And I'm going to multiply by PT, which is 1140 millimeters of mercury. So 2 divided by 10 times 1140 gives me 226 mmHg. I look at the problem and it says, what is the pressure in mmHg? So I'm done. But if they wanted their pressure in something else, then I could just convert it here at the end to whatever unit they want. Go ahead and pause the video and do B on your own. It should be very similar to this last one. So now you were looking for the pressure of neon. So you should have done the fraction of neon times total pressure. Neon, we counted earlier, was 5, so 5 over 10. And then total pressure in this problem, it says it's 205 kPa. So multiplying and dividing, we get 102.5 kPa. But the problem wants their answer in ATM. So I need one more step. I need to convert kPa to ATM. 1 ATM is 101.3 kPa. Multiplying and dividing, I get 1.01 ATM. This problem is similar to the last one, except instead of giving you a picture, they gave you the percentages. So go ahead and pause this video and try A on your own. Restart when you've got an A. So just like before, we're looking for the partial pressure of oxygen. So we need the fraction of oxygen times total pressure. Our fraction in this case, they said oxygen is 20% for every 20 plus 80 or 100. So when it's a percent, it's going to be over 100. And then my total pressure was 1.09 atm. They don't specify what they want the partial pressure in, so the easiest thing would be leave that in atm. So 20 divided by 100 times 1.09 gives me 0.218 atm. So if we were making a representation of the submarine air, what would it look like? Using a total of 10 particles, make sure you include a key. So you can make those particles anything that you would like. The easiest would probably be an open circle and a filled circle. So let's go ahead and say our open circle is nitrogen and our filled circle is oxygen. So go ahead and pause the video and try drawing your representation of that submarine air in the box below. Since we're using 10 particles, that's relatively easy since we have it in percents. 20% of 10 is 2, so oxygen should have 2 particles. And then 80% of 10 is 8, so nitrogen should have 8 particles. Remember that it is a gas, and since it's a gas, it should be filling the box. So that's one thing that you should be making sure that your diagram looks like. And then the nitrogen and oxygen should be randomly spread throughout. So it should be a homogeneous mixture, not hetero, because the nitrogen and oxygen densities are roughly the same. So they should be mixing completely.